Hello and welcome. I am Dr. Pauline Fu. In this lecture, I will present ordinary deferred annuities. So first, I will explain the concept of deferred annuities. Deferred annuity is the first payment is made at a time later than the end of the first payment interval. For example, if you have OSAP, you don't need to make payment right after your graduation. You make payment 6 months after you graduate. So that is the deferred annuities. Okay. The time period from time referred to as now to the starting point of the term of annuity is called the period of deferment. In the example of your OSAP, 6 months is the period of deferment. The number of compounding periods in the period of deferment is designated by the letter D. Okay, represent the number of compounding periods in the period of deferment. Now let's look at example of ordinary deferred annuity. Ordinary means payment is made at the end. So let's look at an example. Calculate the size of payment required at the end of every 6 months to repay a 6-year loan of 20,000 if the payments are deferred for 2 years and the interest is 5% compounded semi-annually. Okay. So in this example, if you draw a diagram, you have a loan 20,000. Now, but the loan will not be paid until after 2 years. So from here to here, you have 2 years. After 2 years, you make repayment for 6 years. So the 6th year, after 2 payments, the 6th year from here to here, that is annuity. Suppose interest is 5% compounded semi-annually. So what is the question here? The question asks you, what is the size of payment? So what is the PMT for the annuity? What is the PMT from here to here? Okay. And the loan is 20,000. The present value 20,000 is here. So this is now our focal point. You have a loan 20,000 here, and you make payment. So what is the size of payment after 2 years? That is the question. Okay. So because we have keyword and this is an ordinary annuity, ordinary. And because you have delayed payment for 2 years, it is deferred annuity. Okay. So we want to solve for PMT here. So this is a similar diagram, okay? We have 20,000 today. We don't make payment until after 2 years. Okay. And D, from today to 2 years, you have 4 because the payment is every 6 months, so D equal to 4. After 2 years, and from here to here, it is 6 years. The payment is paid every half year, so you make 12 payments, N equal to 12 for the annuity here. From here to here, term N equal to 12. Okay. And the question asks you, what is the PMT here? What is PMT? That is the question. Okay. So we do 2 steps. Step 1, we found what is the future value at the end of 2 years. What is future value for this 20,000? So we use this formula, FV equal to PV times 1 plus I raised to power N. This situation N is D. Okay. Interest rate is compounded semi-annually, so 5% divided by 2. Interest rate 5% divided by 2. It is 2.5%, 0.05, 0.025. Okay. So you get the future value. Okay. So this number is here at this point. And this number served as the present value for this annuity. So you use this formula, PV equal to PMT. 1 minus 1 plus I raised to power negative N, N equal to 12, divided by I. So this is I. And 1 equation, 1 unknown, you can solve for PMT. Okay. So this is step 2, actually. So this is a formula method. Okay. Is there any calculator method? Yes. So to do the calculator method, we still follow 2 steps. Step 1, what is the future value for the loan in 2 years? Step 2, what is PMT? Okay. And also we know PY is 2. 1 year you make 2 payments. CY is 2. Interest is compounded semi-annually. And the payment is made at the end. Okay, so we set up the calculator. Second, quit to clear any previous entries. And then second, PY 2. Enter. Down arrow key, CY 2. Enter. Second, quit. And now, enter 20,000 is a present value. 20,000 is PV. Interest is 5. N is 4. Here, see, N is 4. Oops. And for regular compound interest, 0 is PMT. There is no regular payment here, first 2 years. So final step, compute FV. Okay, so you get this number here. And this FV is the present value at here. Okay, so this becomes present value of here, present value. And here you have 12 is term N. 12 is term N. 5 is the interest. We order 5 is interest I. So 0 FV as precaution to clear any previous entries. Remember, you need to enter 4 numbers. Okay. Last step, compute PMT. I get different number. Guess what? Why I get different number? I did this on purpose. Hope you can find the reason. Remember here, I write down here, it is end. Look at what is my computer. It is begin. So first step, you have to change from begin mode to end mode. So I'm going to do it all over again. Okay, so second quit. First step should be end mode. Okay, right now it is BGN begin mode. So you do second begin, second set, second quit. You have nothing on top right corner, means it is end mode. Okay. After it is end mode, you then do set up PY is 2, CY is 2, second quit, and then you do step 1. Okay. Step 1, 20,000. That is the present value. 5 is interest, IY. 4 is term N. 0 PMT, compute FV. You get this number. Okay, $22,076. And this number becomes present value of the annuity. Okay, become present value of the annuity. And for the annuity, 12 is term N, 5 is interest, 0 FV. Final step, compute PMT. See, you get exactly the same number here. Okay, so this example illustrate it is very important to set up the status of your calculator. It is begin mode or it is end mode. So this is a calculator method. Now Excel. In Excel, we still need 2 steps. Step 1, find future value of this 20,000 in 2 years. Okay. So equal FV. Rate 5% divided by 2. NPER is 4. PMT 0. Present value 20,000. I type in negative because I want the result is positive. Actually, it doesn't matter. So this is a present value. Maybe I will enter positive number. Doesn't matter. This is a PV. Type is a 0. So you get this number. Okay. The future value. Now step 2, figure out the PMT equal PMT. rate 5% compounded semi-annually. 12 is a term N. PV, this number is the present value. The future value is 0. Type is 0. So you get PMT. Exactly the same number as we get from calculator. And this is the formula for PMT. Okay. All right. So let's look at other examples involving how to calculate term N for deferred annuities, how to calculate interest. Okay. For how long can you pay 500 at the end of each month out of a fund of 10,000 deposited today at 10.5 compounded monthly if the payments are deferred for 9 years? Okay. So 9 years is here. And you make deposit 10,000. And this is today. And the interest is 10.5% compounded monthly divided by 12. That is a periodic interest I. And then the question asks you for how long. So from here to here, what is term N? That is the question. Maybe I want to use different color. So from here to here, what is this term N? That is the question. And from here to here, it is an annuity. PMT equal to 500. Okay. So for this question, we are asked for term N for this annuity. So 2 steps. Step 1, what is the future value at here? What is the future value here? Okay. And in this case, the D equal to, because it is compounded monthly, D equal to 12 times 9. Okay. 108. So it is a similar method as we just did before, that example. So here I'm just going to use maybe calculator method and Excel method. Okay. So now I'm going to figure out the future value at this point. Okay. So calculator. Second, quit. Make sure it is at the end mode, because see here, end, END, end. So in this question, each month, so PY equal to 12, second PY, 12, enter, down arrow key, CY is 12, enter, down arrow key. Now, calculate the future value at this point after 9 years. So 10,000. 10,000 is, no, this is PV. I'm going to start all again. So PY is a second PY. PY is 12, CY is 12, correct. Now I'm going to enter 10,000. 10,000 is PV, present value. Okay. 10.5. 10.5 is interest. 108 is term N. See here, from here to here, 108. 0 PMT. Calculate FV. So the number is here. Okay. And this FV becomes present value for this annuity. Okay. So this FV becomes present value of this annuity. And this annuity has 500 as payment. Okay. And this annuity, 10.5 is IY interest. Okay. And then do not forget 0 is the FV for this annuity as precaution to clear any previous entries. Last step, compute N, and you get this number. Okay, so this is means if you take 68.28 months, so usually we just round up 69 months. Okay. So this is a calculator method. Excel. So 2 steps. Step 1, calculate future value. Okay. Rate is 10.5%. Compounded monthly, so divided by 12. NPER, 12 months times 9 years. That is actually 108. And then PMT is 0. Present value, negative 10,000. Type 0. Okay. So this is a double check. Yes. So this is the present future value at this point. It becomes present value for this annuity. And for the annuity, the question asks you to solve for NPER, means term N. Rate is 10.5%, compounded monthly. PMT is 500, negative 500. PV, present value is this number. Future value is 0, type is 0. Okay. And you get the same number as we get over here. Okay. So I'm just going to copy these 2 numbers over here. Oops. And the first number is the future value of that loan. Okay. And the second number is the term for the annuity. All right, so this question solved for term N. Let's look at one more question for interest rate. this question here. Payment of 1,000 are due at the end of each year for 5 years. If the payments are deferred for 3 years, and interest is 10% compounded quarterly, what is the present value of the deferred payments? That is the question. Okay. This question asks you, what is the PV? So from here to here is 3 years deferred. And then you have 5 years, that is for annuity. In this annuity, PMT equal to 1,000. And you make payment each year for 5 years, so term N equal to 5. Okay. Because you make payment each year, so PY equal to 1. 1 year you make 1 payment. And interest is compounded quarterly, so CY equal to 4. Here we have situation PY not equal to CY, so this is a general annuities, deferred general annuities. Okay. So what is the question here? The question is, what is the present value here right now? What is the present value here? Okay. Again, we use 2 steps. Step 1, figure out what is the value here. This value is the present value for annuity. What is the present value for this annuity? Remember, annuity starts from here, end from here. Okay, so what is the present value for the annuity? And then step 2, what is the present value here? So 2 steps. Okay. So let's do the step 1 first. What is the present value? So you know PMT, you know N, you know interest. You can figure out the present value. Okay. So let's use calculator to do this. So second equation, there is a keyword END, end means this is end mode. Okay. So PY is 1, CY is 4. Second, PY 1, enter. Down arrow key. CY is 4. Enter. Second, quit. Okay. And now 1,000 is PMT, negative PMT. 10 is interest, IY. 5 is term N. You enter the 3 numbers. Remember, you need to enter 4 numbers. So 0 FV as precaution to clear any previous entries. And now compute PV. So step 1 result is 37.54 cents. Okay. And this PV becomes future value for the first 3 years. Okay. So this number becomes future value. Future value. Okay. Over here. So I entered FV. So I want to solve for PV. 0 is PMT. The first 3 years, not an annuity problem. Okay. And then interest is still the same, 10%. Okay. So 10 is interest. Term N. Okay. For these 3 years, so 3 years, because payment is each year, so but interest is compounded quarterly. So you have to enter D is 12. Okay, 3 times 4, 12. 12 is term N. And final step, compute PV, present value. So this is the present value. Okay. Present value here. So this is a calculator method. Now you can also use Excel, but when you use Excel, because we have PY not equal to CY, you have to calculate equivalent rate per payment period P. Okay. Equivalent rate per payment period P. Remember P equal to 1 plus I raised to power C minus 1. Okay. I is 10% divided by 4. I equal to 10% divided by 4. C equal to CY over PY. So you figure out P, equivalent rate of interest P, and then use this P as rate in Excel. And we did similar question many times. Okay, so I will omit Excel step in this question. This one here, last question in this lecture. This is about compute nominal rate. Mr. Daliwa wants to receive payments of 800 at the end of each month for 10 years. After his retirement in 7 years. If he invests 50,000 now to earn 6% compounded monthly until he retires, what monthly compounded nominal rate of interest must he earn after he retires? Okay. So this is a deferred annuity because he is going to retire in 7 years. From here to here, it is 7 years. This is now. In 7 years, he will retire. After retire, there is an annuity for 10 years. So 10 years from here to here. And during this 10 years, PMT equal to 800. And the term N for 10 years is 10 times 12 because it is every month, receive payment every month. So term N for the annuity, 120. So this is the annuity. And what happened for now? Now he invests 50,000 to earn interest. Okay. So the question asked, and from here to here, the interest is 6% compounded monthly. 6% compounded monthly means divided by 12 is periodic rate. Okay. So our first step is to calculate what is the value here. Step 1. What is the value at the end of 7 years? Step 1. This value is the future value of 50,000. Once you calculated this number, and this number served as a present value for the annuity here, and you get a present value for annuity. You have PMT, you have N, you can figure out what is the interest IY for here. So IY, nominal rate of interest, that is the question. Okay. So let's use a calculator to do it. So second quit. Again, this is the END end. Okay. For the first 7 years, interest is compounded monthly. Okay. So we need to figure out what is the future value here. Okay. So D is actually D. Try to use same color. D equal to 12 times 7. Then 80 equal to 84. Okay. So step 1, calculate future value after 7 years. Okay. So we set up CY, PY first. Second, PY. Okay. PY is 12. Okay. Enter. Down arrow key. CY is 12. Enter. Second, quit. 50,000. 50,000, that is the present value. 6 is interest. 84 is term N. 0 PMT, compute FV. So this is the future value in 7 years. And this future value served as a present value for the annuity here. So just type in, press PV. So this is PV. And then 800. 800 is PMT. 0 is FV. 120 is term N. Now compute IY. So the answer for IY, 4.83%. Okay. So it is 4.83%. So how do we use Excel to do this problem? This is my calculator. The Excel. So step 1, calculate future value here. Okay. So equal FV. Rate is 6%, compounded monthly. NPER is 84. And then PMT is 0. PV negative 50,000. PV type is 0. So this is the future value. This future value becomes present value for this annuity. And the question asks you what is the nominal rate? So Excel equal to RATE rate. Okay. NPER term N 120. PMT negative 800. PV, this number is PV, present value. Future value is 0. Type is 0. Okay. And this rate is actually per month. To get nominal rate, this rate, you have to times 12 to get nominal rate. And change to percentage. See, same number as we get from calculator. Okay. All right. So in summary, this lecture presents ordinary deferred annuities. Usually, you need 2 steps to figure out either present value or term N or interest. Thank you so much for your time. I look forward to see you next time.